So today's lesson, this is writing an equation and a graph from a table of values. We've already done this. We did this in our linear unit, but now we're looking at linear functions. This is 6.2, day 2, so you should have your notes open to that page. Today we will write the equation for a function based on the table and the graph. Rachel starts cycling a distance away from her house at a constant rate. The table shows her distance from home, y meters, as a function of the time she takes to cycle x seconds. So seeing my information here, I can take this table and draw the graph that matches with it. The graph paper didn't really show up here because it's very light. I can see it on my screen. Maybe I'll have to go over and do it on the screen. So I'm going to take my values, my x, time, which is in seconds, and label that axis, and distance, which is my y-axis, and label it in meters. My table of values always gives me the excuse me, the interval that I'm going to count by. So it looks like my y-axis should probably go up by 4s. And my x-axis is counting by 1s. 1, 2, 3, 4, 5. Very small one here. So my first point, 0, 6, right there, that's my y-intercept. 1, 10. My graph paper isn't really showing up here, but you can see it on yours perfectly fine, I'm sure. 2, 14. I have a copy of the notes and it looks pretty clear. 2, 14. 3, 18. Very weighted out today on the smartboard. 4, 22. So halfway between 20 and 22. And 5, 26. So yes, it's a linear function. It's going up at a rate of 4 miles per hour. So my graph would be, well, that's what it's going to, or my equation, that's the next slide that we have here. Can you tell what the slope, the rate is by looking at the table? And I can, because I can see for every increase in my x of 1, my y increases by 4. As my x is increased by 1, my y is increased by 4. That's why I decided to count by 4s on the y-axis. 1, as my x's go up by 1, so now I'm writing 2 and 3. My y's go up by 4. So my delta y over my delta x, this is one way I could do it, just go right to the table. And delta y over delta x, or my slope, is 4 over 1. The other way I can do it is actually to take the slope formula, which says x sub 1, y sub 1, and x sub 2, y sub 2, subtracting those. So my slope formula here, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So if I choose these 2 points from the table, yes, 22 take away 14 over 4 take away 2, I'm going to get 8 over 2, which is the same thing as 4 over 1, which is what I found using the table. For every change in the x value, I have a rate of change of 4 in the y value, or using the slope formula, 4 over 1. So if we know the slope is 4, and the y-intercept started at 6, I know the equation. Y equals mx plus b. M is 4, x plus b is 6. Y equals mx plus b. So we're writing our equation again in the slope-intercept form, the function form. That is the function form of a linear equation, which means in Rachel's situation that she started cycling 6 meters from her house, and she was cycling at a rate of 4 meters per second. So that's her rate of change, her delta y over her delta x. Let's try this one. The table below shows the total distance, y miles, indicated on the odometer of Jason's car and the amount of gasoline, x gallons used on a particular day. Graph the function using 1 unit on the horizontal axis to represent 1 gallon and the interval from 0 to 5, and 1 unit on the vertical axis to represent 30 miles for the y interval from 1,000 to 1,050. Write an algebraic equation for this function. Well, here's my y-intercept. And now I've got to figure out my slope. Well, my slope is going up by 30s for every increase in my x of 1. So delta y over delta x, 30 over 1. So my equation is y equals 30x plus 1,000, my y-intercept. Describe how the slope and the y-intercept of the graph are related to the function. Well, the y-intercept, it's just asking you what does it mean. The y-intercept 1,000 means that the odometer, the thing that tells you how many miles on your car, for instance, so you can have one of these on your bike, the odometer of Jason's car shows 1,000 miles. So there's already 1,000 miles on this car. Must be fairly new. And for every gallon of gas, the odometer goes up 30 miles. 30 miles per gallon. Pretty good. Goes up 30 miles. That's good gas mileage. So answering that carefully. And then the graph on the next page. What is the slope? So we already figured out the slope. I figured out the slope was 30. M equals 30. And I could have done it using my delta y over delta x formula, where it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Or as I showed you on the table on the page prior, that yes, as every x goes up by 1, my y values are going up by 30. The y-intercept is 1,000. I already wrote the equation on the page prior. We know the equation is y equals 30x plus 1,000. And they gave us the direction on the page prior as well, that yes, we're going to count by 30s. 1 unit on the vertical axis represents 30 miles from 1,000 to 1,150. So we've got to put a break here. So we start at 1,000, 1,030, 1,060, 1,090, 1,120, which are just the values that are in my table. 1,150. Whoop, don't forget to label this. Yes, this is distance. And we're keeping track of miles. Distance in miles. And then the other one is gasoline, which we're keeping track of in gallons. So my gallons are from 0, 1, 2, 3, 4, 5 on my table. So just plotting those points. So when x is 0, y is 1,000. When x is 1, it's 1,030. And again, this is very bright, so I'm just approximating. You have graph paper nicely that you can see on your, and it's showing up on my screen. It must just be the smartboard today. Very, very bright. 1,020. And yes, should going up in a straight line, and if you plot those correctly, it does. And there's your linear function of 30 miles per gallon of gas starting at 1,000 miles on the odometer. That's it for today.